Ma'am, shall I allow all the students?
No, they're saying just 1 minute.
Okay.
Actually, after 1 minute, we'll allow, no, sir?
सत्तावीस आहे. आपले पण आहे काही 10 सगळे मिळून 28 30 आहे. Shall I allow, ma'am? Bhakti, ma'am? Bhakti, ma'am, shall I allow all the students?
Yes, sir, you can, please.
Okay, okay.
Yes, sir.
Bhakti madam, we can start.
Yes, sir. Yes, sir. We can start, sir. Can I start? I think there are some students who are yet to join, and if I start, then I'll not be able to admit them. So can we give them 5 minutes? So 2-3 minutes more.
You can start it, madam. I will approve all the students.
Okay, sir. Okay, sure. Sir. Good evening and a warm welcome to everyone present here. I, Ms. Bhakti Thite, Placement Officer at Symbiosis Institute of Geoinformatics, would like to welcome you all for today's session on latest trends in data science, career prospects, and opportunities. Before we begin the webinar, I feel a proud privilege to introduce Symbiosis Institute of Geoinformatics. At SIG, our endeavor is to impart education and skill in the area of spatial science and data science and analytics to create professionals. It helps students to create their own career roadmap. SIG has an inviolable track record of 100% campus project come placement record of its eligible students since inception, and SIG offers a variety of programs including MSc Geoinformatics, MSc Data Science and Spatial Analytics, MTech Geoinformatics and Surveying Technology, certificate courses, photogrammetry, and remote sensing and customized certificate courses. Over the years, SIG has identified the key areas and needs of industries and has enriched the syllabus in terms of both practical and theory. We take all the efforts in the pedagogy, various aspects of training from basic mapping science to GIS development, data mining, to decision making, soft skills, and personality development. The program emphasizes on experimental learning that allows learners to apply concepts learned in the classroom in simulated and real work situations. This is achieved through tools and technologies like deep learning, various packages within Python for data processing, machine learning, data visualization, etc. Case studies and assignments. Carefully chosen real-world cases and assignments are both discussed and used as problem-solving exercises during the program. Dissertation. The fourth semester offers an opportunity for learners to apply their knowledge gained through the program to the real world, like complex projects. The learner is expected to demonstrate understanding of vital principles learned across semesters and their ability to successfully apply these concepts. The global data science market, as you know, is estimated to grow at a CAGR of 30% to reach 140 US billion dollars by 2024, according to a survey of Markets and Markets report. Now I'm going to introduce today's guest, Dr. Shailesh Deshpande and Dr. Janani Shruti Rapur. Dr. Shailesh Deshpande is a senior scientist working at TCS Research and Innovation, TRDDC, Pune. He has over 24 years of experience in research and development in broader areas of machine learning, remote sensing, and so on. Sir has received his Bachelor of Engineering degree in Civil Engineering from Shivaji University in year 1994. Sir received his master's degree in Environmental Sciences and Engineering in 1998 and PhD in 2018 in Hyperspectral Remote Sensing from IIT Bombay. His current research interests include processing of hyperspectral and multispectral remotely sensed data. He is particularly interested in using spectral and spatial properties of the Earth observations to generate meaningful insights. Sir has authored and co-authored over 40 research papers, a few book chapters, and 6 granted patents. He serves as a reviewer for few more important remote sensing journals by IEEE, Elsevier, ISPRS, Taylor and Francis, etc. Some of his recent publications are journal papers, book chapter 1, on spectral library and discrimination analysis of Indian herbal materials. He has a lot of more research papers also to add to it. I would like to also introduce our second speaker for the day. Her name is Dr. Janani Shruti Rapur. Dr. Janani Shruti works as an offering lead in analytics and insights department at TCS Hyderabad. She has over 10 years of professional experience in industry and research. She has graduated from Kakatiya University of Technology and Sciences, Warangal, with a degree in mechanical engineering in year 2012. She started her career in industry as an applied mechanics engineer at Cummins Research and Technology, India, Pune, where she was involved in developing Cummins fuel systems for BS4 Indian emission norms. She later pursued her research interest in IIT Guwahati from 2014 to 2018, where she did her PhD in rotor dynamics, machine learning based predictive maintenance. She worked at Mahindra and Mahindra as a business analytics manager, where she was responsible for driving Industry 4.0 initiatives in product development, manufacturing, supply chain, finance. In her current role at TCS, she is leading the development of cutting edge solutions in supply chain management across the industries. She has more than 15 international journals and conference publications to her credit. Such eminent personalities we have today with us to share the knowledge and experience. I now hand over the session to Dr. Shailesh Deshpande, sir. You may please take over.
Yeah, thanks, Bhakti. Hope I'm audible, right?
Yes, sir. Absolutely. Yes.
Yeah, thanks for this opportunity. It is nice interacting with you. So we can see a lot of students who have joined. So hope we will have an interesting discussion as we go ahead, right? So
Yes.
before we go ahead with our content, let me just highlight where we come from, what are our backgrounds. Already you have given nice introduction. Let me I just add to that. See, TCS is very well-known company, and most of us and the students who have joined also would probably know that it's one of the leading software consultancy. But what I would like to highlight is it's not just about software. What we do is in addition to our day-to-day consultancy project, we have a very big research division also. What we call as a innovation labs, and we have innovation labs at various places. And Shruti also is a part of one of such innovation lab, which is in analytics and insights. So with this a small background, I think Shruti, could you please start?
Sure. Thank you so much, Shailesh. I'll share my screen. Shailesh, please give me a confirmation if you can see my screen.
Yes, it is visible. Yeah. So I'm at the first slide, which is data sciences and industry perspective. Yeah.
Yes. So good evening, everybody. I'm Shruti Rapur, and with me is Dr. Shailesh. So we'll take you through data sciences and industry perspective. We'll try to touch upon all the important areas which we think you should know as students. And if we've missed out on anything, probably you could obviously ask us any questions. We'll be open to taking questions at the end of the session. In today's session, we'll be covering the introduction to data science, a very brief introduction, just to make sure that the audience who are new to data science have some idea on what we are talking about. Then we'll talk about data science applications, industry-wide, and maybe TCS, some success stories of TCS as well. Then we'll talk about data science project lifecycle, what generally happens. when you initiate a data science project. And then we'll talk about what are the different tools and techniques that you should be aware of, or what are the tools and techniques that are available in the market. And then, of course, the most interesting part, we'll talk about the career opportunities as well. So to start with, let's discuss about data science. So data science, as you know, it's science of using the data to discover some meaningful insights or meaningful hidden information that is there in the data. Now that means to say that data is the crux of everything. It's like the bread and butter of a data scientist. Now for that, to understand the scope and width of what data is, we should understand what are the different types of data that are there. So you all know that there is something called as structured data that we see every day almost. The data which has some tabular format, there are some numbers, there are some alphabets, but there is a structure to it. So basically there are structured data, and we have unstructured data, which is estimated to have a volume of 80% of the entire enterprise data. So this could be images, audios, emails, texts, videos, etc., etc. So you name it, anything that cannot be expressed in rows and columns or in a tabular format can be called as an unstructured data. Now, what should you know as data? What is data analytics, and what are the different types of data analytics that you can do with all the structured or unstructured data? So always primitively, we start with descriptive data to descriptive analytics, where we try to understand what has happened in the past, what are the key events that have happened in the past, and what are the key events that are happening right now. So this is more or less information extraction from the data. Then the next is, and the next question is, why has this happened? So this is the diagnostic part, where you try to see what is the reason for something to happen, right? So this is where you come and identify a lead indicator, okay, through analytics support. And predictive is where you will try to identify what will happen in the future. So this is like an early warning system. And then we have prescriptive, what needs to be done. Okay, this is where automation can happen. So if you see, the pink region is where you support as an analytics person, but the purple region is where the human intervention is required, right? As you move away, as you move towards uh, sophisticated automation systems, or sophisticated algorithms, you move more towards automation and lesser human intervention. So that's where we would want to be in the future. But as we come from industry, we would want to tell you about what are the big data challenges that we see today in the industry. So we see issues like data quality. The quality of data is not proper. The data preparation is not properly done. We cannot actually generate any insights from the data without having basic domain knowledge. Then we do not know what data technology we should use. Should we use multiple data technologies, or should we confine to one sort of data technology? Then hiring talent and retaining talent has become a very big challenge with the attrition that is happening, with the demand that is there for data scientists today. Then the next is a very important topic, which is data security. How do you secure your data? How do you make sure that your data is not stolen by somebody, or it's not seen by somebody who is not supposed to see it? And very importantly, we have very few people who understand business and data science together. So that's where we have real dearth of talent. And after all this comes data management and cost. Where do you store the data? How do you pay for that data? How do you manage the data? So all this put together, these are the common industry challenges that you see in big data management. And then I would briefly like to touch upon what is the analytics architecture. So basically, analytics architecture is how does analytics, or where does analytics fit in the entire picture? So first you have your data source. Then from the data source, the data is stored, and then you have processing engines, various batch processing engines, and there's a machine learning algorithm. Into the machine learning algorithm, the data is parsed, and from there you analyze the data and store the data, and then you do the reporting, right? You do the reporting, and that's how you do an orchestration of all your segments in your analytics architecture. Now, after this, I would want Shailesh to please take over and talk about unstructured data and some examples of it.
Yeah, sure, Shruti. Thanks. Yeah. Am I audible?
Yes, Shailesh.
Okay, sure. So as we were discussing about the structured and unstructured data, and Shruti rightly highlighted the fact that 80% of the data is unstructured data. So here it is one example of unstructured data. So this is a map. You can see that map is about a particular parameter, or say over India, and it is about pattern in space. So what I'm trying to highlight over here is just whenever it comes to numeric data, you will typically do a trend analysis. You will identify anomalies, where variety of things, predictive analysis, descriptive analysis, whatever we just discussed, we can do it. But in addition to that, for unstructured data, many times visualization like this is also important. And not only visualization is just for the sake of visualization of the data because it's having special attribute, but at the same time, visualization is also a tool for analysis. So here you can see how the trend, particular trend or particular parameter is varying over a space. So this is a particular map which shows the health of a overall different state, health indicators of a different set. And then one more additional thing about it is that it provides a synaptic view. So in this case, synaptic view is very important to convey the analysis results also. So can you please move to the next slide, Shruti?
Hmm.
Next
One
slide,
second.
please.
Yeah, I'm trying to. Okay.
Yeah, sure. So just like we saw, right? So the trend analysis is important, and not only the trend analysis is important, visualization also is a sort of a technique by which we can analyze or find associations. So on the right hand side, you say image, right? Image is there is a overlay of a special layer which is a map, and map shows a residential area which is shown in the blue. The blue line is a road, and the most of the white spots you see are commercial buildings. Okay, so now here what we are trying to say is that we are trying to find the association between residential buildings and commercial buildings and its proximity to the road. Okay, so you can find out that most of the times the commercial buildings are very nearby the road. So what essentially it does is this visualization, whatever we are using, provides an additional ability to analyze the data and find association, which otherwise will be very difficult to reveal in numeric data. It's not that it's not available in numeric data. Also, it is available as a special coordinates, but then at the same time, if you use visual analytics tool, it will be far more useful than just looking at the numbers. So similarly, on the left hand side, you see a trend over a Maharashtra region. Can you just move to the next? Let me give you now a text example. We saw the unstructured data examples where those were images or maps, or we wanted to use visual aids also for analysis and bringing some meaningful insights which are in the form of association. Now, when it comes to unstructured data, again, text is one of the important one. As you would be very aware that most of the knowledge about the processes or more knowledge about the company or knowledge about the different artifacts about of the company or entities of the company are typically maintained as textual records, right? Take example of this where a company is trying to conduct a employee satisfaction survey, or a given product company is trying to conduct a customer survey, which is very common nowadays, right? So you always have to fill a form and tell you how satisfied you are with a particular product or a particular service, right? So it will have numeric data which can be calculated and aggregated as an average satisfaction index, which is ASI, and you can do a trend analysis. This is a normal analysis you do, but at the same time, for whatever intersection you take, for example, we are talking about the geographies on the left hand side and satisfaction index, which is a chart. Now, for the same intersection, we have to always see what the textual comments are saying, right? So because it is very difficult to integrate it in form of ASI, so what we do is we apply some of the unsupervised techniques, clustering for grouping them together. Each group indicates a category. So here it is showing some of the categories for a employees who are satisfied or they are trying to tell the problems. So for example, canteen and transportation is the area for improvement, or maybe even office infrastructure could be improved. That's what they're saying. So so structured, unstructured data, and especially unstructured data in image form and text format These are the examples, and these are different insights you are looking, you are trying to expect from them. Yeah, over to you, Shruti. Yeah.
Thank you, Shailesh. Now I'll quickly take you through what are the different data science applications, and this is where I would want you all to focus on, to try and understand what is the variety and mix of applications that we see across different businesses. So let's start. In here I've put a few businesses, businesses to be precise, but I would want to definitely make a disclaimer saying that this is not an exhaustive list of businesses that can be there, but this is just an indicative seven very important businesses that we see in our day-to-day lives. So if I just take you through what are the businesses we are talking about, we are talking about banking. Banking is where you do your financial transactions, take loans, any financial services. So all that comes under your bank. Retail is which connects you to the wholesaler or manufacturer who sells you the end product, right? Then telecom, of course, our favorite, which keeps up our communication with our near and dear, and also is enabling the world to become a smaller place, right? Insurance industry is basically to plan for any uncertainty that we are going to see in our lives. It could be a vehicle insurance, it could be a health insurance, it could be a life insurance, it could be anything, any planning for any uncertainty we do through our insurance policies. Then manufacturing is the manufacturing industry basically is a broad based industry which deals with manufacturing of anything starting from your medicines to your automobiles or your airplanes. Anything related to converting a raw material to a finished good is where you talk about manufacturing. Utilities is that industry which basically caters to your daily energy requirements, water requirements, gas pipelines, etc., etc. So those industry which take care of those utility services come under utility industry. And healthcare, of course, the hospitals, the pharmacies, the insurance providers, all that can also come under the healthcare bucket. Now if you closely see, I have actually listed down a few interesting applications, data science applications. But if you again closely see it further, you're going to see that I've highlighted something in red. Can you see that? I've basically highlighted a data science algorithm, not an algorithm, it's a data science method called fraud detection. So, fraud detection is there in banking also, it's there in retail also, it's there in insurance also, it's there in healthcare also, it could be in telecom also. It could be in manufacturing also, it could be in utilities also. So, what is the point that I'm trying to tell you? I'm trying to tell you that fraud detection is basically to identify any anomaly detection, including fraud detection, can be can be a method to identify if there is any deviation from the set processes. So it can be very challenging from a data perspective because it's a bit like finding a needle in a haystack. That is, most interactions are not fraudulent, right? 100, there are 100 transactions, maybe one would be a fraudulent one. So it is just like finding a needle in a haystack. So therefore you need strong business strategy applied and combined with strong machine learning models which could unify and produce the required results. Here I would want to emphasize on the point that understanding of business is as important as understanding data analytics, or if I have to say, it's more important than understanding data analytics. The reason being, data analytics cannot be a standalone business for any for in any major businesses that I'm talking about here. It cannot be a standalone entity that can exist independently. As long as it doesn't embed itself into the business, it is not useful. I hope you understand that. Therefore business knowledge is as important as data analytics, and the way you stitch it together is going to bring you leaps and bounds of success. So let's now deep dive into what is fraud in banking. In banking, fraud detection is a critical activity that can span a series of fraud schemes and fraudulent activities from bank employees to customers alike. It could be phishing, spear phishing, account takeover, SIM swapping, hoax site, and what do you do? What do you make use of as data analytics professional. You'll be making use of cash transactions that are happening. You'll be making use of the customer profile. You'll be making use of customer demography and many other features to basically identify if there are any anomalies in your banking transactions, banking fraudulent or fraud detection in banking. Let's now talk about retail fraud detection. Fraud detection is a critical issue for retailers as well, because it needs to be determined to prevent losses and preserve customer trust. Fraud can originate from customers or people camouflaged as customers, store associates, or external criminals or hackers. The most prominent recent frauds have involved stolen credit card information, fraudulent merchandise return, or fraudulent billing activities, etc. So here we use transaction activities. The data we use is transaction activities, purchasing data, accounts payable, point of sales data, sales projection, warehouse movement, employee shift records, returns, store level video. Then we have traceability of our goods and services, video and audio recording, and other data sources. That all this could put together can help you identify any fraud that is happening in your retail industry. Now let's talk about healthcare. Healthcare is where people's life is at stake. So people are very sentimental about healthcare. When I talk about hospitals, people really get sentimental about it. So if I have to say it this way, when it comes to life, people trust their doctors, and they can go to any extent to get themselves healed. However, here the ethics of the healthcare provider and the doctor are very important. So wherever there is an ethics angle, that's where cheating could happen. That's where fraud could happen, right? Therefore, frauds are very rampant in this industry, and the types of frauds could be kickbacks, where doctors receiving gifts or gift money, or some other illegal transactions from pharmacies, or maybe some diagnostic centers to promote their products or services. Or it could be medically unnecessary services. So if I'm going for a flu treatment and I'm getting a COVID treatment done, then that's a medically unnecessary service, right? And then there is something called as upcoding. Upcoding is where we are generating bills for no services that were rendered to us. Then let's talk about insurance fraud detection. So insurance frauds affect not only the financial health of the insurer, but also innocent people seeking effective insurance coverage. So fraudulent claims are serious financial burden on issuers and result in higher overall insurance costs. So they could be medical billing frauds, claims frauds, life insurance frauds, and many others. Now let's take an example of medical billing fraud. Medical billing fraud is where you design your algorithms to identify if there is any excessive billing for the same diagnosis and same procedure. You'll try to identify excessive number of procedures per day or place of service per day, and identify multiple billings for the same procedure for the same date of service. Highlight any upcoding of procedure, statistically outlying numbers. Locate age inappropriate treatments, like if you're too young and you're getting a treatment which is for old age people, or you're too old to get a treatment to get polio drops, then that's where that is going to trigger a alarm for you. Then you'll identify duplicate charges on patient bills, find doctor and patient belonging to the same residential address, right? Now we've seen that fraud can mean different things to different businesses. But at the end of the day, what we are trying to do is we are trying to do an anomaly detection, right? Therefore, what I would want to make you understand, dear participants, is that though it means solving a different problem for different industries, the methodology is more or less the same. But the data is where all the magic is. That the data is very, very different when it comes to different industries, and the frequency of data and the number of claims that you see are going to be very, very different, right? So this is where I would want to say it's like unity in diversity. You have diversity of businesses, but you have unity in methodology. Now, let me, since I've talked to you about our general banking, let me talk to you also about capital markets. There are multiple frauds that can happen in capital markets also, including circular trading, where there are localized circulation of stocks. I sell stock, somebody else buys it from me, that guy sells to the third person, I buy it from the third person. So we are inflating the stock value internally. So that's a kind of fraud that is there. Then there is pump and dump, where the owner only keeps on buying his own stock to inflate the stock price. Yeah. So TCS has made a solution for had made a fraud model for SEBI, and it has been implemented by SEBI. It's a very successful model where we try to identify any frauds happening in the capital markets, that is the stock markets. Now, let's also now focus on, let's say I'll pick 2 or 3 use cases from, let's say, since I've talked about banking, I'll talk a little bit on telecom, a little bit on manufacturing, and maybe I'll close it there on the data science applications part. So in telecom, let's talk about a story from a customer, from one of our customers, and this is a customer churn model that we had made for one of our telecom customers. So the increasing rate of customer churn has been a biggest threat in telecom industries, right? So especially we could have seen that, we have seen that in when the Geo had come into the industry, and almost everybody tried to flee to Geo, and that's where Airtel, Idea, and all, they have lost their businesses. So it is not only dragging the customer base down, but also affecting the revenue base and impacting heavily on the market share. The objective of the model that we had created in TCS was to identify potential postpaid retail subscribers month on month basic who can port out in the coming period. So we wanted to identify those people who are going to go away from us, right, from the telecom industry. So the data that we tried to use was demographic data. So this is where I would want you to focus on. What is the different variety of data that we have used? We've used demographic data, customer profile, revenue data, CDR data, complaints data, network data, campaigns, historical port out information. And the tools that we had used were RStudio, RShell, Spark, Hive, Impala, Netezza, and the algorithms that we were used were AdaBoost, Ridge, Lasso, C5, GBM, Neural Network, XGBoost, Random Forest. Doing and creating the algorithm and deploying it successfully at the customer's end, we could save a revenue of 3.95 million Malaysian ringgit. So this was for a Malaysian customer. We could actually save 3.95 million Malaysian ringgit. So you understand the quantum, right? Machine learning model could save so much revenue for a company, right? Now let's move on to my favorite area, which is manufacturing. Since I'm a mechanical engineer, I deeply connect to use cases that come from manufacturing. So this was for a leading chemical manufacturer. We tried to do a demand forecasting model. So this particular chemical manufacturer had numerous types of products that he was creating. So in technical terms, these are called as stock keeping units or SKUs. So he was producing numerous types of models, numerous types of products. So what happened is, it was very difficult for him to estimate what is the exact demand going to be in the future for each of the product type, right? As you diversify your product portfolio, your demand forecasting error will keep on increasing, right? So we had to develop a hierarchical forecasting model that could give a higher accuracy and a prediction power in order to improve the overall supply chain performance. So for this, we had used historical demand data, and the data size was about 1 GB, and the tools that we were used was SAS, Teradata, and MS Excel, and we could actually save 10 million US dollars per year for this particular chemical manufacturer. So that's a huge quantum that we had saved for them using a data analytics intervention. Now let's talk about inventory management. So building a safety stock predictive model. So in inventory is basically you are going to maintain inventory because you want to make sure that your customer service levels are high, right? You're able to, whenever there's a customer who's coming, let's say I have a basic grocery store and somebody is coming to buy a surf excel, and I'm going to tell him आज मत आना, कल आना, मैं कल स्टॉक लेके आऊंगा, वो customer क्यों रुकेगा मेरे लिए? He'll immediately flee to another grocery store and buy the product from there. Therefore, it's important for me to maintain the right level of inventory, which is the stock in my manufacturing plant or at my dealers and or at the warehouses, so as to serve the customer at the right time so that I don't lose my customer. So we built a safety stock predictive model to optimize inventory holding while modeling uncertainties due to supply, demand, new product, and part characteristics, while maintaining or improving as a service level. So this particular model that we had done had reduced the inventory management cost to 0.23 million US dollars and held the customer safe a lot every year. Is there a question? I could hear some sound. Okay. I'm assuming there's no.
Later on
So-
for question answers.
Yes.
We are going to give them time later on for the question answers.
Okay. Sure.
So
Sure. Okay.
yeah, sure.
Okay. So the data that we used for this inventory management was daily audit data, part characteristics data, RAND data from almost 2 years. And the tools we had used were Python, R, and MS Excel. Then maybe I'll take one more example and then I'll close it. I'll wrap it up on data science applications. Another very interesting example which comes and which is very talked about is predictive maintenance. So our client was one of the largest engineering conglomerate in the world. The customer wanted to eliminate any unplanned failures so as to reduce maintenance and service costs. So we had created a machine learning model to do predictive maintenance of turbine fuel nozzle failures of a gas turbine, and we could reduce 95% of unplanned maintenance events, and we could save 12.3 million US dollars. Right, so that's a huge saving that we had given for our customer. And the data that we had used were turbine parameter data around exhaust flow temperature data. I hear some noise. If there's a question, please stop me. Or if there's no question, can the audience please?
It's not the question.
Yeah.
There's some voice which is coming out, right? Just hold on.
Yes, I think somebody has unmuted their mic. All right. So I'll continue. So we had used the historical parameters data of the turbine to establish and create the predictive model. Now, in all these use cases, it was not done by a data scientist alone. It was done by a group of people who would understand data, who would understand the business, who were the subject matter experts in understanding the business problems. So all put together, that's one team that works together to create a solution of data science. A standalone data scientist may not be always capable enough of solving a data science problem. So that is something that you as a data scientist should appreciate, that collaboration is very important when it comes to data sciences or data analytics. Let's move on. Let's talk about what are the different methods or the latest methods that we see in data sciences. So we see something called as recommender systems. We see speech recognition. We see sensor data analytics, computer vision, natural language processing, and optimization. Let's go one by one through each of them. So what is a recommender system? So recommender system is, they are algorithms aimed at suggesting relevant items to user, and they basically tell you what you want to buy. They basically tell you what you might need in the future. So where do you see them? You definitely see them in Netflix, you see them in your Amazon Prime Video, you see them on your Flipkarts, you see them on your Amazons, where they constantly keep on telling that customer who has bought this also wanted to buy this. Customer who had viewed this also wanted to view this. And in Netflix, if you closely observe, they're going to tell you that 95% probability that you're going to like this particular content, or they'll say 85% probability that you're going to like this content. So all these are recommendation engines that are working. So when I've talked about the 7 business verticals before, just to tell you, these are used in retail and these are used in insurance, and they can be used in many other places. I have just mentioned 2 here because I just wanted to tell you that it can be used in diverse industries. Now, let me give you an example of a recommender system that we had built. Okay. So this was for a B2B food shopping industry. So the highlights and challenges were that post-pandemic, everybody shifted to e-commerce as a channel. Everybody wanted to buy their stuff on your Amazons, Flipkarts, Zomatos, Swiggies, etc. Now there is a peak in at-home customer consumption. So customer is not coming to the grocery store or the retailer, and he is buying directly from his home. So it was imperative for CPG to adapt big data analytics, AI ML solution to beat the competition. So the customer challenges were that revenue growth by increasing efficiency of e-commerce website, maximize customer average transaction value, capitalize upon post-pandemic shopping trends, right? So TCS, what did it do? It tackled nuances of manufacturer, distributor, and retailer, accommodated strategic human recommendations for product launches, business decision making, and recommendation based is latest customer preferences, enhanced both average transaction value and wallet share, and therefore we could upsell and cross sell we could generate upsell and cross sell opportunities, and we could increase 1% of the revenue of that particular firm in 9 to 12 months, which was accounting to almost 40 million US dollars. So that's what we did in the recommendation system space. Now, speech recognition. Let's talk about what is speech recognition. These are technologies that enable us to recognize, translate spoken English and into usable format for the algorithm to respond to our commands. So one very good example is your Alexa, your Cortana, your Google Assistant, and Siri. So all these are basically your speech recognition algorithms, and which businesses use them? Banking, healthcare, your insurance can use it. Anybody can use it as such. Now let's move on to sensor-based data analytics. Okay. So what is sensor-based data analytics? Here you use sensor data. Now that's where the tricky part is. Sensor data, the data is of high frequency and of high volume. Hence, knowing and understanding the right aggregation techniques is critical to understand to take out useful information from the data. Here we use terms like sampling rate, sampling frequency, number of samples per second, etc. Or samples in one bucket of data. So there are many terms that we use. We use something called as Nyquist frequency. So a lot of things that are there. And why is sensor data so important? Because sensor data contains high value information that can be used for many things like predictive maintenance. We can use it for your heart rate diagnostics. You can use it for your health monitoring. Many use cases of your IoT sensor data. In fact, your autonomous vehicles also use sensor data to understand the road conditions. Also use sensor data into a large extent. Fitbit, Tesla, Apple, you name it, all the high-tech companies use IoT sensor data. Now, what are the types of businesses that can use it? Manufacturing, utilities. Manufacturing is growing in a big way to use sensor data. That's what we call as Industry 4.0 transformation. But many other industries have also simultaneously started using sensor data analytics. Now, let's move on. What is computer vision? Computer vision is they enable systems to derive meaningful information from digital images, videos, visual inputs, etc. So one use case for computer vision, one of the leading aviation aviation engine manufacturers wanted to identify if there was any engine defects in their engine whenever the aircraft landed or before it took off. So for that, what it would do is it would send its personnel who would maintenance personnel who would go and manually check the engine, and it would be very time consuming, and also when the weather wasn't conducive, like let's say it is snowing outside, it's raining outside, it's very sunny outside, it becomes very difficult for personnel to go and manually check the data. So what the client had done is they had provided us with a lot of image information of the engine or where the parts fail, and we created an algorithm which reduced which could basically identify or classify the defect, and it reduced the time and efforts or in the first level judgment of the defect and severity by 40 to 50%, which is very, very huge. So where do you see them? You see them in your Gs, your Teslas, your Ford, your Audi, your Rolls Royce. Many places can use your image analytics. Even again, autonomous vehicles can also use image analytics. Now let's talk about natural language processing. Natural language processing are programs that understand and interpret the natural language data. So where do you see them? You see them in your Google, you see them in your chatbots. These days, even an Amazon chatbot, if you've ever used an Amazon chatbot or a Zomato chatbot, you must have seen that you barely will be okay, you barely will be able to recognize if you're talking to a human or you're talking to a computer on the other side. So these are very useful to improve your customer satisfaction index, right? So that will especially they are used in your banking, your healthcare, your insurance services. It's you name it, every industry wants to move towards this chatbot so that they can automate many processes and reduce the return time, right? Then let's talk about optimization. Optimization is basically to make sure that you're using minimum to achieve maximum, right? Whatever you want to, or you want to maximize your profitability, minimize your time, minimize your time of transaction, whatever it could be. So optimization is basically maximizing or minimizing whatever is your objective function. So let me give you an example. This was for a fiberglass manufacturing company. So this manufacturing company basically was seeing that the manufactured glass used to be found with defects, and that would even a small crack or a little bubble on the in the glass, they would have to reject it. Therefore, they wanted to estimate like what are the parameters or how should I maintain my process parameters so as to eliminate these defects. So that's where TCS had used a child analysis to identify drivers for the product damage and wastage, and machine learning analytic model for in-time quality prediction was used. Real-time reporting and control framework was used to highlight ongoing manufacturing issues or those that might hit the production process in the near future. In issues detected at a sensor data machine part level. So we could prevent the glass production wastage by 30%, and wastage of 1% of overall produce, and an estimated savings value was about 15 million US dollars. So you see, the impact of these kinds of machine learning algorithms or these methods is huge for industries. That's why the industries are adapting so quickly. They want to just dive into any benefit that they can get through data analytics, and that's where we need talented professionals like you to get onboarded get onboarded into various industries and help them achieve their best revenue possible. Now, let me quickly touch upon data science project life cycle. It's important for you to understand what is data science project life cycle. So, data science project lifecycle, when I talk about it, basically starts from understanding the business or understanding the business problem. So you have to ask relevant questions, and then you have to define objective of your problem. What is it you have to do? Just because you know a deep learning algorithm, you know your RNNs, you know your LSTMs, you're not going to apply that everywhere and anywhere. You have to first understand if that's even a machine, if it's even a data science problem or not, and do we have sufficient data to solve the problem. Then the next thing comes is you try to understand the data. So this is where you'll need your subject matter experts, you will need operations people who would come to your rescue and help you understand what are the different features that are there in the data, what does the abbreviation stand for, what does the number signify, is it a nominal number, is it an ordinal number, what does it mean. So that's where you understand your data, form hypothesis about your problem by visually analyzing the data. Then comes data preparation. You cleanse your data by handling the inconsistencies or the missing values, select important features, and construct most meaningful ones using the raw available data. While you're doing data preparation, you will have to again sometimes go back and revisit your data understanding, go back and revisit your business understanding. So I would always say that this is not a one-sided circle. It will always have a bi-directional flow as and when required. Then you do your data validation, check for the accuracy of data. So let's say the temperature, supposing I'm reporting temperature of Hyderabad, and I've reported it as 100 degrees Celsius today. So that's
You
obviously
want to
wrong
be
data,
there
right?
before
You have
lunch,
to do
before
some,
dinner, you can be there.
you have to do some
Sure.
common sense based
Mine
validations and
only at
also
night I want to finish my PPT tonight and sleep. That's why. Saiba, I want to do and my Ola Sagala come.
there's somebody who's not on mute. It will be really helpful if you could go on mute. Thank you so much. So yeah, so then we have data validation, which is a very important step, and then comes your modeling part, which is something that interests you the most. You do you judge first, you identify what sort of a model is required. Does it require a supervised, unsupervised? Does it require a classification, a regression? Does it require is it a reinforcement problem? Is it a natural language processing problem? What is it? So you basically identify that and use the model. And it doesn't just mean you have to use one model. You might have to test 3-4 models or use ensemble models to basically identify which is the best model that is going to give you the desired output. Then you do an evaluation of your model, and then you deploy the model. And deploying is in the sense you cannot create the model and save it in your computer and the job is done. It doesn't happen like that. You have to make sure that it is available to the end user. So you deploy it in his premise, or you deploy it on cloud, on some a place where you are getting your data, where you're merging your data and also your machine learning model. After you do the deployment, you have to constantly observe how your model is actually working. Is it doing up to the mark, or do you need some improvements in your model? And that's where comes the enhancement and the sustenance part. So you do your enhancement and sustenance, and once you understand that there is enhancements that is required in your model, you go back to your modeling step, redefine your model, add some more features to it, do this process again. So this is your basic data science project life cycle. Can somebody tell me, are we doing good on time?
Yes, ma'am.
Bharti?
Yes, ma'am.
Okay, great. Okay, let's move on. Now I would want Shailesh to please come forward and take us through data science tools and techniques. Oops.
So Shruti has already summarized some of the skills required in earlier slide. So this is a kind of a summary and a more holistic view of what kind of skills one may require. Of course, the basic fundamental maths and statistics is a very integral part of it. Without that, probably you're not able to do data analysis, especially multivariate data analysis, multivariate statistics. This is very important because most of the data you'll try to analyze, it will not be a simple single dimensional or two dimensional data. It will have typically many attributes, many dimensions, which could go it could be hundreds also. Many times in text data it could be 2000 also. So multivariate data statistics is a very important branch, important tool in data analyst scientist hand, and then it is absolutely essential. One should have these fundamental skills. Of course, with math as a basic foundational background, you would probably need additional skills in machine learning, which is unsupervised, supervised learning, as we discussed. What they do is they provide a view, they provide a model or mechanisms by which we can, using a data, you can predict the values of your parameter of interest. Okay, so and in unsupervised technique, typically, as we have discussed, probably that if you don't know what is that we expect from the data, we are not we don't know what exactly we are looking for, but we just want to extract some of the interesting patterns, then unsupervised technique will come in picture. But all in all, this machine learning is very important set of skills one should have. So this leads naturally to some of the additional skills in computer sciences about data modeling, data handling, so on and so forth. So of course the scripts and all these things, though that part we also see. Software development is again overlapping field where it is related to data modeling, computer sciences, and programming. What I would say is that maybe you may not focus much on software development. That would be okay, but still the scripting skills you should have. So, like for example, Python scripts, R script, or maybe even Perl scripts actually you would write. Perl scripts typically are useful in handling text data. So that kind of maybe if it is OLAP data, then you would like to build a cube and slice that data in multiple dimensions of your interest. So in such cases, processing data using some scripts, having building automated scripts, that kind of programming will be certainly required. Of course, as a data scientist, you may not be not always in the development of a large software platform or product, but still these kind of skills will be required. And one of the most important one is a domain and business knowledge. So those numbers don't mean anything if they are not interpreted in the context of the domain. Okay. Uh, so it is like treating a patient without actually observing a patient, right? So that should not happen. The data should be always interpreted in context, and this is the most important part, which is always missed out. So I have seen many deep learning engineers or machine learning scientists. What they will do is take a data. They will not even worry about whether what is the quality of annotation, and they will run it through the standard exercise of training data, and then modeling and testing and deploying and all these things, and they'll say horrible results. Sometimes even 30% accuracy also is written by a deep learning model if you don't understand the data well. Okay, so overall this is, so as you can see, again it is multidisciplinary, and that is also a very important aspect of it. Probably the right strategy or right way to approach this would be gaining as much as multidisciplinary knowledge as possible. You cannot be, it's like being a master of all and not just jack of all and master of none. It should be, you should become master of all actually, not just one domain. Yeah, can you Shruti move to the next slide, please? Are there any questions? By the way, it will be more helpful if we okay,
Sorry,
fine. So
Shailesh, I didn't get you.
yeah, okay. I'll assume that there are no questions. So this, as we discussed, some of the important aspects of data analysis, some of the techniques, machine learning, and we also understood that data may not come in a single form. Data may come in text, numbers, images, and so on and so forth. So this is one technique which where we are trying to just describe in detail a little bit more about what is known as a hierarchical process, analytical hierarchical process. So this is where this process should be known by all the data scientists, no matter what. So like, though it is what you can say naturally inclined towards GIS kind of analysis, but it's not limited to that. It is very basic underlying theme or basic process which allows a certain way of modeling of data if data is coming from multiple sources. So I'll explain with this diagram. So let's say I want to capture a sustainability of a given area. Now, as I can see, that sustainability of the area, given area, in environmental sense or economic sense, or socio-economic sense, will depend upon many factors. Okay, it could be maybe wells in that region. It assures that water supply is ample. It could be a canal network. It could be soil health. By the way, we are talking about here agriculture sustainability. Okay. Then elevation, and then probably productivity, and so on and so forth. Also, it will depend upon the proximity to market, consumers, and so on. So you can have some of the features of the real world. So what we are trying to do is we are trying to see that all the influencing attributes have data in different format. So wells are numbers. I can have just point data, but I can always map them in a layer. So this becomes a one layer. Similarly, canal network is again, there is a strong visual representation of the data. So I can always represent as a numeric data with some IDs and its coordinates, but that coordinates are having linear features as we see over here. Okay. So canal network is another type. Soil health. Soil health is now all the data, point data and line data you see as a vector data. Now soil health is distributed over a region. Let us say we are trying to calculate the soil health over a say area of 30 meter by 30 meter. Each will represent a cell in a region, and each cell will have different soil health parameters. So again, we can use image data, we can use survey data, you can use any method for acquiring the data, but ultimately that data would be represented as a raster grid, as a grid over that. Now, if you see that once we model all these things, integrating them in a certain way is required, right? So this is where GIS kind of mechanism, or GIS is just one way to do it. Of course, you can always integrate that data in variety of forms, but integration of the data in all format is required. Okay. So these kind of processes where you integrate data, and now you can apply and represent or create an index by summing up them. Now, instead of just summing up these values, you can apply some weights to it. For each, say, let's say agriculture sustainability is more, if water is there, it is more relevant to the sustainability of the agriculture area. Soil health is more relevant than elevation probably. Now, in such cases, what you are trying to do is you are inserting some weight in the system, and the weight could be given by expert, or it could be learned from the data. So now what happens is with all these systems, you can in GIS nicely you can integrate all of them, and you can represent the sustainability as an index, and it can be represented as a weighted summation over some of the attributes. Okay. And data always can come from variety of sources. So satellite is one information. Then your survey data, survey is another mechanism. Surveys by where people enter values in the form is another method. So what I'm trying to highlight again is that the methods of acquiring data could be different, which are expressed in the right hand side. It could be image, it could be a survey, it could be a survey, textual data, and text. Then we need to integrate them in some system. How we integrate them? We integrate them by creating an index. Index is nothing but a weighted summation over some of the attributes. Each attribute is represented as a layer. Their GIS kind of system will be helpful. And each attribute is weighted by some weights. It could be any value between 1 to 10, 1 to 5. It can decide that. And those weights could be given by expert, or it could be learned by system using machine learning techniques. So what I feel is that this kind of mechanism is very important and very central to many complex data analysis projects. If it is just a numeric data, if it is just image data, probably you can deal with the only one technique, which is computer vision or natural language processing, or maybe just a simple numerical data analysis for trains or whatever that might be. But when it comes to real life complex problems, whatever skills we saw in the earlier slides, we have to integrate them in a nice manner with this given framework, which is AHP. Hope I think the idea is clear in terms of how we want to integrate, why we want to integrate, and how the data coming from different sources leads to some important metric, which is like index. If there are no questions, I think I will request Shruti to take it forward.
Okay. Now let's touch upon what are the different data analytics tools and techniques. So there are plethora of tools and techniques that are there, right from cloud technology to your visualization platforms. So with evolving data science, I think one thing that every data scientist or every aspiring data scientist should keep in mind is you have to always be relevant in your field. That means you have to keep on upgrading yourself with latest trends and technologies, so as to keep yourself up to date on how however the technology is progressing. Maybe 20 years before, people would have rarely thought that cloud would become such an important thing, but today if you see, cloud is mainly dominating many spheres of businesses. So I would quickly touch upon what are the different cloud technologies that are there, or the prominent ones that are there. We have Amazon AWS, we have Azure, we have Google Cloud Platform, we also have SAP Cloud. And then we have different database management systems. Database management systems are, or tools are basically your server management systems, data querying systems, SQL and NoSQL servers. So SQL servers are basically for your structured data, and NoSQL servers are for your unstructured data. And if it is in manageable size, then the open source ones are your MongoDB, Cassandra, and if they are bigger ones, then you go into Hadoop and allied technologies. So you have MySQL, Microsoft SQL Server, Oracle Database Management, MongoDB, Ignis, and we have Cassandra. For data modeling, of course, this is our favorite topic. So data modeling, we have Python, SAS, R, PyTorch, TensorFlow, MATLAB, Keras. So we have many open source as well as licensed data modeling techniques. Then coming to analytics platform, analytics platforms are those which are basically no code or low code platforms where you have a good UI user interface where you can drag and drop and create your machine learning model. So many such analytics platforms are Alteryx, IBM, TIBCO, DataRobot, Databricks, SAS, MathWorks, etc. Then visualization platforms, of course, I would say that Excel is the father of any tool. In fact, Excel is where everybody started, and many organizations are very still very much hooked to Excel. So you can never ignore Excel's importance, not just in visualization, but in many things, like even data modeling to some extent. You do through Excel. Data management you do through Excel. Many places it's done like that. So in your visualization, you have Excel, you have Power BI, you have Click, you have Tableau. Now, what am I trying to tell you by just showing you these products? What I'm trying to tell you is, right now as students, you are very focused in this data modeling area, and that too on specific technologies like PyR, PyTorch, TensorFlow, maybe to some extent MATLAB, Keras and all. But I would want you to open your minds and be very agile in your approach to at least know a little bit on what is cloud, where is it is used, what are the different packages that are there in cloud, what are different querying languages, at least know the basic SQL queries, and so that you can write your little SQL scripts. And you should also know a little bit on what are the analytics platforms. Of course, this is a little too much to ask, but visualization is something that you can at least pick up. So you should have some basic understanding of other tools and techniques also, so that when you're working or collaborating in a team, you will be able to understand each other's language. You'll be able to understand what the other person is trying to tell you. Moving on, I wanted to put some supervised and unsupervised techniques in front of you, but I think this is very theoretical. If I talk about this, you all are studying this data analytics course, and therefore I would not want to waste too much time in supervised, unsupervised reinforcement learning and what are the data trends and techniques. I would only say that it does not always require a hacksaw to pull out a nail from a ground. Okay, many times you don't even have to go to deep learning techniques to solve a problem. It could be solved maybe using a logistic regression. It could be solved maybe using a linear regression itself. So in fact, if you know Andrew Negg, who is one of the pioneers in machine learning and data science, who's from University of Stanford, he once said that most organizations in Silicon Valley are still stuck to logistic regression only, and they are reaping huge benefits from there. Therefore, I would only tell you that just because you have a axe, just because you have a very sharpened hacksaw, you don't have to use it to solve problems which don't really need it. Sometimes even a hammer or sometimes even your hand can do it. So remember that always complicated algorithms are not required. Now let's talk about career opportunities. Career opportunities is one area which everybody wants to know about, like what is the future going to be. In fact, today while we were starting, Bhakti made a very important statement. She was telling that there's a 40% CAGR of data science opportunities worldwide, and that's how the opportunities are growing year on year, right? So of course the opportunities are growing. Of course there's a dearth for knowledge, but it is important, a dearth for talent, but it is important for you to identify your niche. When I say niche, you have to identify where do you want to fit in that big picture of data analytics. Do you want to be an analytics consultant? And then, so when I say analytics consultant, that person is the one who provides solutions to improve the efficiency and solve a company's problem. So I go to a company, ask them what their problem is, maybe see what they are not able to see, and come up with a solution to the problem. Okay. So for that, you have to be very functionally knowledgeable. You should know the domain very well. You should know, like if you're going to an automotive industry, you should know about automotive industry. You should have some business experience. You should have some analytics understanding. You should know your basic data sciences. You should know what are machine learning algorithms. You should know how they are applied, how to do a little bit of coding, maybe to run one or two pilots. You should be able to drive the project yourself. So that kind of analytics understanding is required. And also working experience in any industry or domain is a very, very big added advantage. So generally the roles that analytics consulting field people generally are offered analytics consultant role to start with. And obviously there's a career progression as we move forward. Then data services, a data engineer is an IT worker whose primary job is to prepare data for analytical and operational use. These software engineers are typically responsible for building data pipelines to bring together information from different sources. So they should have an idea of different ETL systems. They should have an idea of where the data is originating from, where do I transport it to, what is the data frequency, and then understanding maybe querying tools like SQL, NoSQL, understanding different data architectures. To design if the organization needs an on-prem server, or does the organization require a cloud server, how big the cloud server is required, how many clients need to be engaged, how many people need to be given licenses, license management, etc., etc. All this comes under your data services. So here you need to know something like MS SQL, PostgreSQL, MongoDB, AWS, Azure, GCP, one of these. I'm not saying you should know everything, but at least some of these things need to be known. So the role that you will get into is a data engineer, right? Then coming next is data scientists, who I should say are analytical experts, and they have both mathematical knowledge, they have their statistics knowledge, they have their domain knowledge. So they are very, very versatile people. Like Shailesh was just mentioning, they need to be very, very versatile, and they use industry knowledge, contextual understanding, and then they design your machine learning or analytical models to solve a business problem. So here you need to have statistics, you need to know programming, you need to know what the business is, you need to know how do you develop process, you have to develop analytical process understanding, and also you should have articulation skills. So you generally end up as a data scientist, right? Then visualization, as Shailesh was previously mentioning, visualization is very, very important. It's if you make a beautiful, complex machine learning algorithm, what do I benefit if I'm not able to see the results? I should be able to see the results, right? So it is very important to articulate, compile all your results into a very readable and absorbable or assimilatable format. So a data visualization developer is someone who creates these graphic representations. Their primary responsibilities are to produce visual depictions of text-based data that reveal patterns, trends, and correlations between different points. So they should have a knowledge of visualization software like Tableau, Power BI, or your Click, or there are many others. SAS has its own analytics platform, Spotfire, Tipco, Spotfire, etc. And they should have business understanding also. It is going to be very helpful in KPI definition, which is key performance indicator definition. And they should also know a little bit on database management. They should know a little bit on SQL and PostgreSQL, or some kind of database management too. So you generally end up as a visualization developer. Now, whenever there is a assignment, whenever there's an analytics problem, you need all these four people to sit together and solve the problem together. It is not going to happen that only a data scientist, without the help of a data service, data engineer, or without the help of a consultant, or without the help of visualization, could visualization developer could succeed in whatever he is trying to do. He will be able to succeed in developing a model which may not be business, which may not have business relevance, which may not be using the right data, or which, even if it is using the right data and has business significance, is not understandable by the end user. That's where your visualization comes. Therefore, I strongly want to tell you this, that it's about collaboration and collective working and continuous knowledge building that makes a data scientist wholesome. That's where all the magic sauce lies. That's where everything is present. Now, since we are talking about career opportunities, I thought it's important for you to understand that data is the center of everything for a data scientist. Therefore, you should know what are the different open source data sources that are there, that you should definitely explore as a student to build some models. So data sources like Kaggle. So if you ever wanted already prepared data in a structured form, then make it your first choice to go to. Kaggle datasets are not only open accessible datasets, they are formatted better, and you can find variety of file types like CSVs, JSON, SQLite, BigQuery, many different types of files you will find. Then the next place where you should go to for data is UCI ML repo. The UCI machine learning repository is a collection of databases, domain theories, and data generators that are used by machine learning community for empirical analysis of machine learning algorithms. Then the next one is Quandl, QUANDL, Quandl. Resource provides free data sets for data science community, which is designed for professionals and delivers financial, economic, and alternative data for people worldwide. They cover almost two types of data, that is time series data and tables. Then we have government data of available US government data on data.gov, and we have Indian government data on data.gov.in. So these sites are particularly designed to make sure that only that data points which can be used publicly are available on this website. So make sure you go through these websites to get some understanding on different data types, what are the different sources of data, and appreciate the data also. Then apart from this, I think hackathons, data science hackathons can be challenging to crack, and they might be very useful for you to hone your data science skills. So you can in fact, they can let you earn some money also in a fun way. So you have many platforms that offer hackathons, which include Machine Hack, Kaggle, Data Crunch, Data Hack, and they have many data science hackathons and competitions, and many times these are real world problems. So that's where you should actually get exposed to. Just give it a try whenever you get some time. Apart from that, we have different blogs written in data science. In fact, in our Indian context, I personally used to go through Analytics Vidya towards data science. These are two important websites that I would always go through. But apart from that, there are different other blogs that you must follow, like Data Science Central, Smart Data Collective, What's the Big Data, No Free Hunch, Inside Big Data, Simply Statistics, Data Flow, Data Science 101, Data Economy, Data Science Report. So all these have very, very interesting articles, latest trends. And I think these are some blogs that you must read to keep yourself updated in this field of data science. So with by giving taking you through all this, I hope you got the flavor of industry, you got the flavor of what career opportunities you might aspire for. And I wish to wish that you all we wish that you all flourish in beautiful colors and you become great data scientists bringing about a change in this world. Saying that, thank you very much for your patient listening. We are open to questions.
Yes, now if you have any questions, students, you can please ask questions. You can put it in your
Hope we were
screen.
able to keep you awake.
Yes, of course. I hope the students were also interested to learn. There was a good learning. It was an interactive, it was a good session between both of you. Now the students would like to interact with you and they have some questions which they'd like to ask to you. Students, you can put the questions in your chat box also. If you would like, you can unmute and also ask the questions.
Yeah, ma'am. Can I take a chance? Yeah, thank you, ma'am, Shruti ma'am and Shailesh sir. I have a doubt about what this machine learning, artificial intelligence, and deep learning to do in this data science.
May I
Can
know
you
who
repeat your question? Your voice was breaking a little. Can you just?
Yeah, my name is Shrikant. I like to know about what the machine learning and deep learning and artificial intelligence, how it will connect with data science.
Okay,
Shailesh,
Shruti,
you
you
would
would like
want
to go?
Okay, I'll take that. So, data science, as Shailesh was mentioning, no, it has mathematics, statistics, it has computer science and IT, and it has domain and business knowledge. So all this put together, the culmination of all this, the mixture of all this is data science. So machine learning is an important part of the mathematics and statistics circle. I'll just share my screen. Maybe Shailesh, you could once more take
Yeah,
us
please.
through
Please
that
go ahead. Yeah, just
slide.
I will add to, yeah.
Yeah, I'll just share my. Shrikant, if you're able to see, so if you see, data science is basically an intersection of all this, right? And machine learning is an important part of data science. Data science is the art of using data to solve a business problem. It could be using business logics also and data, or it could be using a sophisticated machine learning algorithm and which uses data. So, Shailesh, you could please add.
Just to add to this, see, typically what we are doing many times is that interested in churning the data, right? So typically, let's say you have given a simple calculation and it's a one page, there are 10 numbers, you want to add it. You can manually do it, right? There is no advantage, right? So why we need a computer system or why you're using data sciences, many things, many tools, whatever we are discussing is that where you have huge volume of data and you want to do something with that. And typically that something to do with is that you would like to understand the pattern, you would like to understand and predict a phenomena. So typically how humans do is that, okay, we'll see the data and based on that we'll summarize that data in some kind of knowledge and we'll use that knowledge whenever we see a next instance of the data. Say for example, looking at the weather, you want to decide whether you want to play or not. This is a very classical example of machine learning, right? Now in such cases, what we are trying to do is we are looking at the phenomena and we are making a decision which is based on the data. So what machine learning tries to do is, of course, this is a very basic introduction, is that it is looking at the data. It is trying to distill that data in some kind of formation of some kind of information or knowledge, which could be a statistical knowledge, which could be a probability, which could be some other discriminators, and then it is trying to predict a particular parameter for you. So machine learning plays a very key role in that. Okay, AI is a very broad term used for many techniques where we want to replicate human intelligence for a given task. Okay, it could be a driving a car, it could be analyzing a data, it could be anything. But when it comes to AI has many disciplines. Machine learning is one of the disciplines of AI. So typical other broad areas in AI are knowledge based systems, where what you do is you encode the rules in some English like language, and system tries to use those rules. Okay, many of our knowledge, whenever you use, we have very prescribed form of rules or steps. If this is a condition, then we will take certain actions. If that it is raining, they will not go out. If it is raining, we will take an umbrella. These are very fixed deterministic rules, right? We know the conditions, we know exact actions. Such kind of decisions, such kind of knowledge can be easily encoded in rules. So there is a large body of AI which deals with that, which is typically called as a knowledge based system or production systems. The other is natural language processing, which I'm discussing. Other is machine learning. These are, of course, broad categories. There are many other categories which we are not discussing, but broadly speaking. So machine learning is where we are looking at the data, interpreting the data, trying to distill that data in some form, some way where we can utilize it for prediction. Shruti was giving an example of regression equation many times. So regression equation is one of such example, right? So what we are trying to do is, let's say I have some of the attributes, and I want to predict the accident probability at a particular place, and I'm calculating traffic volume, road width, and weather conditions. These three conditions I want to predict the probability of accidents. Then I can collect the data, thousands of records, and I can run through them a regression equation, and regression will understand the various parameters internally, and then it will predict. It will try to predict the probabilities. This is just one example. There are many such examples. So typical tools in our hand in when it comes to machine learning are probabilities, probability rules, Bayesian rule, if you know, and now modern techniques like deep learning, where network is represented and final equation is represented weighted summation. Okay, so this is in general. Hope we are able to answer your question. If you want additional details, let us know. That's not a problem.
I'll just add to what Shailesh said. So data science, if you see, it's a science of solving the problem. Machine learning is a tool that will enable data science to solve the problem. So basically, Shailesh, are you on mute?
Right, very true.
Yeah.
No, it's
So
just true. I'm just yeah.
yeah, so basically, data science is a conjunction of your IT, your business understanding, your mathematics and everything. And this is just a tool that will enable you to solve a data science problem.
Right.
Thanks for the question, Srikanth.
Yes, ma'am.
Sir.
Thank you.
Hello.
Hello.
Is it?
Hello, sir.
Yes,
We are
we
able to
can
hear
hear
you. Yeah, please go ahead.
Hello. Sir, I just want to ask you about this. Sir, how can you suggest how can we approach while selecting a particular domain? If like as you said, sir, about in finance sector, manufacturing sector, if we don't have any such like specialty in anything, so how to approach, like how to know, how do you get to know that this is the domain, this is for me and I should try in this field?
This answer is very tricky.
Uh,
So what are you like? You should begin with that first. What are of your interest? It could be anything. It could be even watching movie and creating a recommender system, or it could be anything which you like. It could be a game also. Okay. So once you have enough contact with that, you'll understand the internals of it, and then once you have detailed understanding of what domain, abstracting that to other domain would be relatively easy. Okay. So whatever. So and then given these topics like broad engineering disciplines, broad science disciplines, by this time certainly you would know like where are what is your main interest. Okay, another way I define interest is always that, say, let's say, of course you are trying to graduate, and of course you are trying to get a job, and then you'll have certain dreams, but I ask myself a question always. If when it comes to interest, I say that if nobody is giving to me money for this, will I do it? And if I say, if my answer to that is yes, then I'll say it is of my interest. Okay, So like that, whatever I am doing is, if somebody is not giving money, I'll do it. Okay, that's how it is. So if you find that topic for you, where if people are not going to give you money, still you'll do it. Okay.
Okay, sir.
I'll just add to what Shailesh said. So what you could do probably is in your area of study, whatever is your area of study, try to explore and deep dive and find if you find some data science applications at all. Let's say I don't know what you're studying right now, but maybe if you're an engineer or if you're doing your post graduation, you try to identify your interest in. As I said, I can second Shailesh on that key. Does data interest you at all? Do you like coding, or you like reading a lot or writing a lot about something? You could be a data science blogger also, for all we know. So there's the enormous opportunity, and it's all about finding that for yourself, I think, instead of following the herd.
So
I think
currently
we
you're
have
part of
received
what?
one. Sorry.
Geoinformatics course or data science course?
So data science.
And there I think some courses on geoinformatics are covered, right?
Yes, sir.
Okay, so
Yes,
essentially
sir.
you would
Spatial
be
analytics is there. Data
right,
science and spatial.
exactly. So you see, typically you would be very interested in going out, and do you trek a lot?
So not yeah, not very much. Sometimes yes, sir.
Okay, anything of your interest you can begin. That's what we are trying to suggest you. Anything of your
Yes, sir.
interest.
I got it,
It
sir.
could be
What
anything.
you're
It
trying.
could be even as absurd as probably just trying to see where the best food junction is. Okay, that also
Okay,
could
sir.
be a analysis problem. That could be also translated into very nice analysis problem.
Okay, sir. Thank you, sir.
I think we have a question in the chat box. What challenges are faced when we try to integrate data science techniques for analyzing the data obtained through GIS or remote sensing technologies? Sahil
Who is
Purohit,
that?
yeah, he's a student. He is
Okay,
from
okay,
data science, and he is one of a polished coordinator of placement
okay,
cell
okay.
also. Yes, sir.
So Shruti, can you just present that slide where it explains the AHP process, and then probably it is exactly what that was the
Yes.
intention of that slide, where so with GIS and remote sensing, what you should know is this AHP process. You should internalize that AHP process which I have mentioned, and you should understand how the numeric data translates into geospatial data. For example, wells, right? So number of wells in a particular area is just a point data. It's a point. You say, okay, Pune region 100 wells, Satara region 200 wells, maybe Mumbai region, whatever that might be. So location and point data to get translated into area. Most of the geospatial analytics problems are the problems where you want to understand geospatial distribution of your problem, right? Or maybe here we are predicting sustainability. Another example could be, I was talking about food junctions, right? So let's say I want to set up a hotel, and I want to identify a best location of the hotel. Then same thing I'm going to do. I'm going to see what are the attributes for the locating. It should be near Ferguson Road. It should be maybe near some other mall or something like that. It should be near college, whatever that might be. So all these can become attribute. Each one of them will have its representation in spatial domain, which is a map, and each such attribute becomes a layer. Once they become layer, you can add them, subtract them. You can manipulate them mathematically. And weightage is the where which plays a key role, where you can manipulate them. So you can say that, okay, I want to have food which is easy for college going students, which is, so that is my audience, or that is my those are my customers, that is my section. Then you can tweak that accordingly. So in that case, you can give a higher weightage to the distance to the college, right? So this is of course just example, but again to highlight it, integrating that information, actually understanding the domain and identifying attributes is also very important. So you need to have clear idea about what is important for locating a hotel, what is important for sustainability. Another classical example is landslide. Let's say I want to identify landslide prone area. Then we should know what are the influencing factor for landslide. It could be water, it could be a slope, it could be soil geology, it could be many other things, right? So, and all those important attributes should be able to consider them. Is it okay, or shall I elaborate more on this?
So
it's clear.
Okay. And
okay.
especially when it comes to remote sensing interactions, as you can see, probably many of these attributes directly are given by remote sensing. So, for example, I want to know how many main buildings are away from my possible location. Then I can use satellite image and identify buildings and represent it. So you can sometimes consider remote sensing as a mapping technology, underlying mapping technology. At the same time, you can see that as a technology for giving attribute data. For example, wells. Now let us say for a given area, I don't have map, okay, and let's assume simply it's very simplistic data. My wells are clearly circular wells, and I can identify from the aerial image. I can actually apply. I can take a sortie. I can fly a drone over a given area, and then actually I can actually calculate the wells, and then that goes as a layer, one of the layer in this kind of process, as you see. Okay. So each of these attributes over here also you can see all of them can be actually calculated by remote sensing. Wells also can be identified remote sensing. Roads also can be identified remote sensing. Canal network, as I'm saying. Soil health also can be identified remote sensing. But again, it is a once you study enough, you will reach a maturity where you'll be able to clearly understand which is important, which is more important, and which is the tool we should use. For example, soil health, though you can use remote sensing, it may be easy to use just existing maps, right? So that kind of it will go with it will come with practice and solving some of the similar problems.
I think we have one more question. I think there are a lot of questions again here in the pipeline. Ma'am,
Hello.
TCS provides various internships. Can you brief us about internships provided by TCS? How can we apply and how should we prepare for getting an internship?
I think
Okay.
Shailesh,
Yeah, please, Shruti, please go ahead.
Shailesh, I think you should take it. You've been in TCS for longer.
Okay. Yeah, see, for internship, as we try to solve these problems, some of the interesting problems, and uh, s- we 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 try to take interns who are interested in, first of all, solving this problem, working with us, and have reasonable skills. And we have internal process where we evaluate them. So there is a exam which one has to take, and then with that, especially this is true for research. For other business units, it might be not that stringent, but for research, essentially, when we take interns for research, solving research problems, we expect them to understand many basic technologies well, so that they can contribute well to the project. At the same time, they also gain something out of it in terms of knowledge and all that. So with that perspective, we expect that they are very well conversant with the problem they are trying to solve. They are very good in some of the tools and techniques we discuss. Especially nowadays, machine learning is a very it plays very important role, right? So having good hands-on on machine learning is very essential. And sometimes it's not necessarily that you are expected to really solve a problem right from the scratch. You are going to, of course, work with scientists like us or Shruti, and then with us, you are going to work on a problem. So if not some fundamental understanding, at least implementation and understanding you should be very well aware of. You should, given a problem, given a data, you should be able to implement that deep learning pipeline in, say, 1 week, 3 days, something like that. I'm just giving example. Of course, other fundamental understanding of underlying math and deep learning technology or machine learning technology or AHP like process, remote sensing, for example. I mainly work in remote sensing, right? So their understanding of computer vision, object detection using satellite imagery is going to be it is going to be helpful, certainly. And ideally speaking, we look for long-term interaction. So 3 months at least. More than 3 months is desirable. So most of the research problem, to have some dents, to have some understanding, it takes more than 3 months for sure. So you have to keep all these things in mind. And of course, informal interaction with us in variety of by using variety of modes is always welcome, in the sense that, see, if you're not interested, we will not able to work together. It is as simple as that. Your interest is of utmost importance to us also. Okay, so to see that, to genuinely let us know that you are interested is also equally important. Okay, so hope I answered the question.
Hello.
हेलो
या
सर, मेरा एक क्वेश्चन है। सर, अज्यूम कीजिए कि मैं एक फाइनेंस कंसल्टेंसी में काम करता हूँ और वहाँ पे एक बहुत मेजर इशू है कि जो लोन रिकवरी रेट है वो बिल्कुल ही लो है सर वहाँ पे। और उस लोन रिकवरी रेट है तो बिल्कुल लो है। तो सर, जो मशीन लर्निंग टेक्निक है वो कैसे हेल्प कर सकती है सर उसको रिड्यूस करने में, या उसको कैसे प्रॉब्लम सॉल्व कर सकती है वो?
So Shruti,
इसके
would you
I
like
बारे
to
में।
think
take that?
सॉरी सर।
should I take it or will you take it?
Yeah, please take it. Yeah, that's what I was suggesting. Could you take it?
Okay, sure. This is basically Piyush. This is ये basically एक risk management का analytics है. Basically to identify if you are giving risky loans or क्या हम are we giving returnable loans? Are people good enough to return loans? तो उसके लिए हम बहुत सारे data use करते हैं. आजकल जब loans देते हैं तो validation होता है, background check होता है. तो बहुत सारी चीजें करते हैं, जैसे डेमोग्राफी का डेटा लेते हैं. डेमोग्राफी मतलब उस बंदे का एज प्रोफाइल क्या है, उन्होंने प्रीवियसली कोई लोन्स लिए हैं क्या, अगर लिए हैं तो रिटर्न किए हैं क्या, क्या ईएमआईज भर रहे हैं, डिफॉल्ट कुछ है क्या, तो वो सब देखते हैं. अपार्ट फ्रॉम दैट they'll also see उसके फैमिली में और कोई किसी ने लोन लिया है क्या, शायद इन्होंने नहीं लिया किसी और ने लिया है क्या. उसके बाद they'll also see what is his earning capability, कितने महीनों से he is earning and कितने महीनों से उनको जॉब है और सैलरी कितना है, and do they have security, is the security document valid. So all these they do a lot of ये सब डेटा लेके वो और उनके बैंक सेविंग्स अकाउंट का भी ट्रांजैक्शंस देखते रहते हैं कि इनके सेविंग्स अकाउंट में मिनिमम बैलेंस रहता है कि हमेशा वो पूरा बैलेंस निल हो जाता है एंड ऑफ द मंथ. सो इवन इन इफ यू यूज योर क्रेडिट कार्ड, नो, आपको क्रेडिट कार्ड यूज करते वक्त आपको एक स्कोर मिलता है, सिबिल का एक स्कोर मिलता है कि हाँ करेक्ट, वो स्कोर के हिसाब से ही आपको लोन्स मिलते हैं. नेक्स्ट टाइम जब व्हेन यू अप्लाई फॉर अ लोन, इफ योर स्कोर इज वेरी लो, दैट मींस यू आर नॉट रीपेइंग योर क्रेडिट कार्ड लोन्स, then that's where your loans will get rejected by a bank. So all these kinds of risk management analytics are done, mostly in major banks they are done, but mostly जो loans default होते हैं, banks know that many times they know that they are going to get defaulted because generally गांव वगैरह में जहाँ पे loans देते हैं, they know that people cannot pay the bank back, but still they take the risk and give the loan. Many times it happens like that.
ओके मैम, ओके मैम, इंश्योरेंस या सेक्टर में इसके लिए क्या मतलब स्कोप है सर? मैम थोड़ा बहुत इलैबोरेट कर सकते हैं? मशीन लर्निंग क्या हेल्प कर सकती है?
हाँ, इंश्योरेंस में क्या होता है ना कि इंश्योरेंस में रिस्क एक अलग कॉन्सेप्ट है, फ्रॉड एक अलग कॉन्सेप्ट है. रिस्क में क्या होता है कि सपोजिंग देयर इज अ पर्सन हु इज 65 or 70 years old and he is coming to take a health insurance. You know that guy is susceptible to, he is going to get unhealthy very soon. So that's why you make sure that you look at that person's health profile मतलब उन्होंने कितनी बार कितने दफे वो हॉस्पिटल गए हैं, उन्होंने क्या चेकअप्स कराया, उनके कोई क्रिटिकल कंडीशंस है क्या, और अगर क्रिटिकल कंडीशंस है तो वो इलाज करा रहे हैं कि नहीं करा रहे हैं, उसके हिसाब से आपका प्रीमियम डिसाइड होता है. तो इसीलिए आप अगर 20 साल के हो और आप हेल्थ इंश्योरेंस लेते हो तो आपका प्रीमियम बहुत कम रहता है. वही आप 60 साल के हो जाओगे और आप हेल्थ इंश्योरेंस लोगे ना तो आपका प्रीमियम बहुत ज्यादा बढ़ जाता है. वो कौन कैलकुलेट कर रहा है, कैसे कैलकुलेट कर रहा है, इट इज नॉट समबडी लाइक मी एंड यू सिटिंग टुगेदर एंड डिसाइडिंग कि ठीक है इससे ऊपर कोई भी आएगा तो हम ऐसे देंगे. ऐसा नहीं होता है. वो पीछे एक स्टैटिस्टिकल टेक्निक होता है जिससे वो कैलकुलेट होता है कि ठीक है ये बंदा he is 65 years old, he has high blood pressure, he has sugar, he has multiple ailments, and these are the kinds of treatments that he is going for. So the health insurance people are very very smart, that what they do is they make sure that in the clauses it's written कि हम ये treatment provide नहीं करेंगे, हम ये treatment provide नहीं करेंगे करके वो specifically बताते हैं ताकि it doesn't come on to them, और उनका प्रीमियम भी बहुत हाई रहता है. और this is again Piyush, this is for risk, but for
ओके मैम.
if you're talking about fraud, then fraud में बहुत सारी होती है कि कोई एक बंदा होता है जो suicide करता है and he wants life insurance cover for his family. He makes sure that the suicide looks like a natural death. So they have to do a lot of deep diving and digging into see if that is a real genuine case or it's a fraud that is happening. So वैसे बहुत सारी चीजें होती है, insurance में भी होती है.
मैम फिर ये जो डेटा है ये कहाँ से कलेक्ट करना होगा, जैसे
in general what happens is insurance providers, when you go to take an insurance, the insurance provider has a tie up with some data providers also. ठीक है, लाइक मैं सिंपल एग्जांपल बताती हूँ. मैंने एक गाड़ी खरीदा, ठीक है, मैंने एक कार खरीदा है और मैंने उसके ऊपर थर्ड पार्टी इंश्योरेंस का लिया है. आई वांट टू टेक एन इंश्योरेंस ऑन माय कार. नाउ my manufacturer knows how I'm using my car because I go to servicing. हमेशा मैं सर्विसिंग पे जाती हूँ. तो वो सर्विसिंग का डेटा जो है वो डेटा मोनेटाइज करते हैं मतलब वो डेटा बेचते हैं इंश्योरेंस पीपल को कि आप ये डेटा लो, उसके हिसाब से आप अपना प्रीमियम डिसाइड करो. एक्सीडेंट कवर जो भी, जैसे इफ आई एम राइट नाउ 30 years old and I have a very rash driving habit, let's say, and I always am into accidents. Now obviously my premium will be high, right? If there's somebody who's a very sensible driver, उनका प्रीमियम कम होगा. और कौन बताएगा वो चीजें मेरा मैन्युफैक्चरर ही बताएगा मेरा सर्विस प्रोवाइडर को, इंश्योरेंस सर्विस प्रोवाइडर को. दिस कॉन्सेप्ट इज कॉल्ड एज डेटा मोनेटाइजेशन. बेसिकली यू सेल डेटा. इफ somebody is collecting data, they sell it to different parties so that they leverage that to upsell or cross sell their products.
ओके मैम, बहुत चीजें क्लियर हुई. थैंक यू मैम.
Good evening, mentors. So,
Good evening.
Yeah. So I remember you from the orientation program, and you mentioned about like data is the new oil. So my question to both of you is, what skill sets or how do we need to, as aspiring data scientists, what skill sets we need to churn ourselves with for right now? And we have our internships coming upon. So what skill sets we should look upon, or what we can invite mostly?
Okay, so may I please understand your background? Are you an undergraduate student or a postgraduate student?
Postgraduate student.
In what domain?
Ma'am, I did my BSc non-medical, now data science in spatial analytics.
Okay, so what I would suggest is, first of all, you should be thorough with your curriculum. That is what is required as the first step. That's the basic. So you should be thorough with your curriculum, and I think, as I was telling you, you should keep reading a lot of blogs to understand the latest trends and techniques. And also, there are many hackathons and competitions that happen. You should always, it doesn't matter if you win or lose, but it matters that you participate and you try to learn. So I think, like data science is an evolving field. You have to constantly keep learning. And what do you have to learn? It all depends on what you want to do. Supposing you want to be a deep learning expert, then you are going to make sure that your skills are toned in that way. You learn a lot about deep learning. What are the different deep learning techniques? What are the different advanced deep learning techniques? And what are the packages that you use in Python, TensorFlow for doing a deep learning algorithm? Now, do you want to be a data scientist or a data evangelist who basically knows a lot about many machine learning algorithms and will need basis want to learn something, or you want to be an AI specialist, you want to be a data scientist? So I was telling you, right, you have to decide on those verticals where you want to fall in and accordingly hone your skills. And there are multiple places from where you can learn. In fact, because you're saying that your internships are around the corner, I would say that you wisely choose your internship so that you use that time very well to hone your skills too. I hope that answers.
Yes, ma'am. Thank you so much, ma'am.
I think there's one question in the chat box: how data science technologies can be used in pharmaceutical companies, mainly in drug development? Is it necessary to know SAS to go work as a data scientist?
Okay, a very interesting question. So thanks to COVID, we all realized that pharmaceutical industries, drug developers, they have seen a tremendous pull from the customers, from the governments. Everybody wanted a quick solution, to find the vaccine for the this what do I say, vaccine for your COVID, and many other things that we had to do. So in fact, I should say AI and ML has helped many pharmaceutical industries, in fact researchers, to come up with a drug very quickly, with a vaccine very quickly. The reason being, they had used historically archived data. So as you know that there are different types of viruses that were there, like SARS and many other viruses that were there. So they used those data. They used the drug or the vaccination ability of different types of data to basically come out with the right mix of how do they make their vaccination. So data analytics was used in a big way. In fact, even if I have to just elaborate on this, uh, to identify what level of infection happened for a COVID patient also, they were trying to see if there are any problem, any nodes that were appearing in the lungs, right? So lots of image processing was used to identify if that was a severe COVID case, or it was a nominal COVID case which could be treated. In fact, even when drug productions were happening, especially remdesivir and all the other drugs that were produced, they had to optimization was used to basically identify कि कहाँ पे कितना drug produce होना है, what will be the demand, what is the demand going to be, how should the vaccinations be supplied across the globe, so that the people who want vaccinations are delivered at the right time. So lots of network optimization, many techniques, you name it, it was there. And because that's how we could basically revive and come out of the situation very quickly. In fact, I have to say that India had been very quick in giving its fight back to COVID, and we really fought it back in a very right way, very quick way, and we had used analytics in a big way to do that.
Let me just add one very interesting example of data analytics in pharmaceutical industry. So typically what happens is that whenever you are trying to manufacture a drug tablets, there is something called as excipient, which is any material which is edible, and it is just added. It is not a main pharmaceutical ingredient. And there is something called the API, right, which is active pharmaceutical ingredient. So as you know that remote sensing is one of the technique, right? So and there is one what is called as a hyperspectral data, and in the lab also you can with a spectrometer or some similar such instrument you can take a reading. So what we had received was a data about a particular pharmaceutical company, and we received a data about those tablets, powder form of those tablets, and we wanted to analyze how much quantity of excipient was there, how much API was there, and then there are 2-3 stages it was tablet was going through, right? So and then we wanted to see whether particular excipient and addition of that, how it is affecting the actual drug delay in the sense when it is ingested. So you can see that this analytics or data analysis is applicable anywhere in overall process chain. So it is though typically it may be applied where lots of data is there. At the same time, it could be applied in such cases also where the data from sensor is coming in and you have to interpret it in some way.
One question I always had, Shailesh sir, can I ask you that question? It was about the app which was put up, Arogya Setu app. How did it actually help to trace the contact? I just always had this question and wanted to ask
Arogya
you.
Setu, in a sense, the COVID Arogya Setu.
Yes, the
It has
COVID
GPS
Arogya.
coordinates. In what way you are saying tracing?
How could it trace the people around you? If someone was positive, it used to give a sensation.
They feed the information, right? So they provide some information, and as you see this the approach, right? So you take some parameters, you apply some weights. So you'll have some symptoms, right? Symptom A, symptom B, symptom C, and the degree of positiveness is nothing but a weighted summation of these attributes. Okay. That is a mathematical form of it. Otherwise, GPS location provides you how many people are around you and all that, and that target. So they both the things are linked, right? So and then this was good in the sense the form was very simple. They had asked only limited information, which was easy to gather. It was not a long form.
Right.
Otherwise, people will not enter it. And then it had very few important parameters which could be easily integrated into whether you are likely to be positive or there is some problem on. And see, in this case, the idea was that any person having COVID should not be missed out, right?
Right. Right. Right.
So already in that sense, here you can see the implications of weight. So I know that if he's having very low fever and cough, the moment says cough, then I'm going to have add more weightage to it. Okay, so
Right.
this probably simple answer to it. Of course, there are many other things which you can do. Probably like you can see how a particular person, you can understand it his network from, let's
Right.
say, from social media. You can understand how he's connected, how many friends he has, then how
Mhm.
typically he travels. If I plot a path of his meetings and all these things within a week time, then I can establish his influence area, right? So then I know that okay, this guy is dangerous because he is moving all around the Pune. This guy should be stopped, right? So of course this was
Right, sir.
preemptive action. I'm not sure whether that kind of preemptive action was taken, but because we just applied very standard levers in this case because we just locked down, right? So
Right.
but yes, yeah, there are some other interesting things also one can do in a sense that the current model, which is used by most of the experts in medical domain, is based on the exposure and your ability, adaptivity, and all that. Okay, now there is no geospatial component to it. It is just a temporal model, like given a time, how it will affect.
Right.
So geospatial attribution can be also added, which I was also suggesting that path, person, influence factor of that person.
Correct. Correct. Correct.
Of course,
So,
and then this is just one way to look at it. There could be good part of the data analysis is always we can come up with many interesting ways to look at it, many interesting approach to look at it. You can just say, okay, I will identify personal attributes of that person, saying his demographic background, educational background, and all that, and from that I will predict that how many people he can meet, rather than measuring complex data, which is path, where he all meets. And I can say, okay, he's a college going student. He loves movies based on his other records. Then I'll say I will flag him. He's one who should not go away, who should not leave his home, because otherwise he will infect more people, right? So
right.
one can imagine many such things, and it is a combination of what we need and what we have, and striking good balance of that to probably quickly arrive at the answer we are looking for.
Right. 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 So, I think all the questions are done. There's one question here. In telecommunication domain, targeted marketing can also be done by SEO, search engine optimization. Then how data science can come in role instead of SEO?
Yeah, Shailesh, will you take that or should I take it?
Now, let me just add, first thing is that first of all, whatever you said is also a data analysis, right? It's outcome of data analysis, isn't it?
Right. Right.
So yeah, so I will yeah, please Shruti, yeah, go ahead, yeah.
Yeah, apart from search engine optimization, you can do many other things like targeted marketing. You know, supposing there is a person in Himachal Pradesh and you would want to do targeted marketing to him, targeted customized plans to him. That's how you make sure that your product is always preferred over the others. You give discount coupons. Supposing you're seeing that somebody is going to churn out, you're going to first do churn analytics, and you're going to see that somebody is going to churn out. You're going to say, hey, I'm going to add another 5 rupees extra balance to your account. So that's how you keep your customer engaged. For customer retention, that's how you do it. There are many analytics that are customer facing that are done. These are just a few examples. I'm sure I've not even covered the spectrum, but search engine optimization is definitely one, but there are many other techniques that can be used as well.
See, one of the examples in the presentation also you see, right? So typically, which the customer engagement point we are talking about. So you need to understand what customer is saying. Then he will typically, in addition to numeric values, he will enter his comments also. How you integrate them, how you summarize them, right?
Sentiment
So
analysis.
exactly, yeah. So there are multiple ways to look at it. Yeah.
I think there's one more question there. Somebody was asking about operations research. I think that was a very important point that I wanted to cover as well.
Right.
So, operations research is an additional or an added skill to your data science. It doesn't optimization is obviously very important. If you have it, then nothing like it. So what all comes under operations research is linear programming, mixed integer linear programming, heuristics, optimization. So you should know at least one optimization tool like cplex or python solver, etc. And generally somebody who's an OR expert can get into roles like OR analyst, OR expert, and you generally have to know about mathematical optimization modeling, and it can serve industries like logistics, supply chain management, airline business, network optimization, and then even in your manufacturing, there's a lot of optimization that happens. So that's what I wanted to give my two pieces on that, if that answered whoever asked that question. Okay.
To some attributes. So, for example, one of the problem we're discussing, like let's say we want to identify a location of a particular industry. In COVID case also we discussed, right? Like let's say we want to set up a particular equipment factory or equipment workshop where it should be, right? Now in such cases again, it goes back to the AHP process. We can identify attribute. All these attributes can be collected using remotely sensed data. You can see, because let us say I want to put my building next to the road, so then road can be detected using remotely sensed data, right, or satellite image. So let's say again I want to put my workshop or whatever that is near residential area or away from residential area. Then I need to know from the city where the residential area is, right? Another example is like, see, urban growth is one of the typical problem, right, we face. And then modeling urban growth is a very challenging problem. So there is a typical way of modeling it. It's called the Markovian model. What it does is essentially it will look at the, let's imagine grid. Let's imagine image. It's a pixel. We understand that. I am assuming that. And let's say there is a central pixel which is a vegetation. All the surrounding pixels are building. Okay. All the surrounding areas or all the surrounding region is developed as a building, and only central portion, some portions, let's say 30 meter by 30 meter or 100 meter, is just a farmland. Okay. Now, in the next stage of development cycle, the farmland is going to change to building. That is a typical way it will happen, right? Because most of the, as it was so what it is trying to tell you is it is trying to a behavioral rule in terms of city development stages. Now, if I want to extract it and create a translate into transition probabilities, I need to study the images over decade, right? And understand what is the transition between those areas. Like, okay, whether the surrounded by a building is changed to building, or whether surrounded by soil area is changed to building. Okay, whatever that might be. Okay. Now that all can be derived from the remote sensing, and again, using any machine learning technique, again we can have predictive models. So Markov model is one of them. Another could be simple regression based predictive models, or other we can have sophisticated or either other shallow machine learning techniques. So these are some of the examples. Another example in construction industry could be
I
even
think
analysis of the materials, right?
yeah.
Hello, Shruti, you're saying something?
Yeah, I was just adding to what you said, Shailesh. I was thinking even the smart cities mission that government of India has done, where you're trying to find unused lands and do town planning,
Absolutely, exactly.
congestion management, and all that. All that also needs
Precisely. Even for that matter, let's say I want to plan a city for reducing its carbon emission. Then in that case, what I should do is the residential area, which is a workforce, should be in proximity to the commercial area, which is, or maybe SEZ kind of software park kind of thing. Right now, there in Pune, one is at Hinjawadi and one workforce is in Hadapsar, right? So your traveling trips are going to be more than if they had been in proximity. So can we create a zoning strategy in such a way that it is reduced? So there also what Shruti was mentioning, in some way we need to optimize those zoning regions in such a way that carbon is reduced, right? So, and
correct
all such things
sustainability.
are a result of some sophisticated data analysis tool or technique, which could be machine learning, which could be multivariate data analysis, which could be anomaly detection, it could be at the same time, data acquisition is all challenge many times. But here we can use remote sensing and GIS underlying backbone for doing all these things. So again, as you can see that this is a very good example where integration of all the technologies and integration of all the data formats modes is coming into play to solve particular problem.
Right, and just adding to that, we can even in construction industry for your procurement, buying from suppliers, and all that also to do the right selection of suppliers or logistics provider and all that also you can use machine learning, I think.
Yeah, another just to extend that point, let us say I have a 5 suppliers which provide ready mix. Okay, ready mix is a type of concrete where it is made in a factory and it is supplied to a particular site. Now each one would have it will have quality associated with it, and each of your site will be some distance away from that. How I map these suppliers to the sites in optimal way? It is a data analysis problem, right? And where the optimization will play important role. Again, maybe we can take simple temporal data, and we say that, oh, this supplier was a good based on the past history. We can develop some model. That way, we can treat that as a geospatial optimization problem also. So it will all depend upon which kind of outcome is suitable in a given setup.
Right.
Okay. You have any other things to say, sir? Or can we sum up the program?
It was nice interacting with all of you. Probably last time also I had suggested was that maybe if this interaction is arranged in person, it
Yes,
would be
that
very helpful to
we have
the students as well.
100% offline.
Yeah, and then see this online mode adds a little bit of
Correct.
formal tone to it. If we
Right,
had been meet in person, then rather than giving talk like this, I would have really
Of course, we are planning to invite.
like to talk to people directly, talk to students directly, and interact.
Right. So we are in fact waiting to invite you to the campus very soon. We'll be doing that, sir. Today we understood very well that in today's world, properly leveraged data can give organizations of all types of a competitive advantage. What you can say, companies now handle vast amounts of data on a daily basis, and there is an unparalleled demand for professionals in this space. In SIT's Data Science and Spatial Analytics course, here we introduce beginners to the fundamental concepts of data analytics through real-world case studies and examples. You learn about project life cycles and the differences between data analytics, data science, and machine learning, building an analytics framework using analytics tools to draw business insights. Thank you, sir and ma'am, for a wonderful session. Every good things come to an end. So here we are at the end of the program. I would like to extend my vote of thanks to Dr. Shailesh and Dr. Janani Shruti for their ideas and elegance of explaining everything so minutely. I also extend thanks to all the faculty members and my dear students for their enormous cooperation for the webinar. Also to the participants who have asked questions. Thank you so much. Last but not the least, I also would like to thank SIT for organizing such a brilliant webinar and looking forward to such many more events. And probably we'll be having those events offline as suggested. Thank you so much for your time.
Thank you and all the best.
Yes, thank you so
Yeah,
much.
thanks. All the best. Yeah, thanks.
Thank you. Thank you so much.